Good to have you on Fascinating Frontiers, Episode 61, coming to you on May 2nd, 2026. Here's your space and science briefing. NASA's lithium-fed nuclear thruster has been tested for the first time, advancing options for Mars missions. A laser communications terminal provided high-definition views during the Artemis II mission around the moon. This technology allowed millions to follow the crew's 10-day journey in greater detail than previous radio systems. The system enabled the transmission of much clearer footage than what we saw in earlier missions. Data travels via a narrow beam of light at the speed of light, requiring extreme alignment precision. This approach represents a significant step forward in how we communicate with spacecraft on deep space missions. The success during Artemis II highlights the potential for future lunar and planetary exploration. To understand the remarkable engineering behind this capability, we have a special deep dive into how laser communications actually work from space. If we scale the distance from Earth to the Moon down to just 1 kilometer, the challenge becomes clear. A laser communication beam would still need to hit a receiver the size of a small coin, while both the spacecraft and the ground station move at orbital speeds. The process starts with the spacecraft modulating data onto a narrow beam of light. That beam travels through space at 300,000 kilometers per second to reach a ground-based telescope. This method supports data rates high enough for live, high-definition video streams, which is a big improvement over radio frequency systems. During the Artemis II mission, this made it possible for millions to watch detailed footage of the crew's journey. Alignment requires extreme accuracy, using advanced tracking systems to handle the motion and atmospheric effects. One remaining challenge is maintaining reliable performance when the line of sight passes close to the sun, where interference might disrupt the signal. NASA has conducted the first test of a lithium-fed nuclear thruster. This next-generation system could enable more efficient propulsion for human journeys to Mars. The thruster uses nuclear power to heat and expel lithium propellant for greater efficiency on long-duration flights. The successful test validates the basic concept and opens the door to future spacecraft integration. This development brings a novel propulsion concept to life in the lab environment. It promises greater efficiency for long-duration space travel. This could significantly shorten the time required for missions to Mars. Engineers are now looking toward integrating this technology into actual spacecraft designs. The first-ever test of a lithium-fed nuclear thruster has brought this concept to life in a controlled setting. Nuclear power heats the lithium propellant, which is then expelled to generate thrust. This approach offers much greater efficiency compared to traditional chemical rockets for long trips. The test confirmed that the basic idea works as expected under lab conditions. With this validation, the focus shifts to making it ready for real space missions. It could make journeys to Mars much quicker than current methods allow. The question now is how soon we might see this thruster powering an actual spacecraft beyond Earth orbit. The Federal Aviation Administration has indicated a net date of May 12th for the next Starship test flight. This approval clears the regulatory path for SpaceX's ongoing vehicle development. The test flight represents the next phase in the vehicle's development. Regulatory clearance like this is essential for continuing the test program. It shows that the project is moving ahead as planned. The focus now shifts to the actual launch preparations. We can expect more updates as the date approaches. Following the successful Artemis II lunar flyby, experts are outlining the next steps in the program. The focus is on building infrastructure for a sustained human presence on the Moon and beyond. These plans focus on creating the conditions for longer-term operations on the lunar surface. The goal is to move beyond short visits to something more permanent. This phase will involve more robotic and eventually crewed missions to the Moon. It builds directly on the achievements of the Artemis II flight. The strategy emphasizes collaboration and sustainable practices for the future. The Artemis II crew appeared on The Tonight Show to share their experiences. They shared laughs, emotional moments, and advice for aspiring astronauts. The astronauts discussed daily life in space during their 10-day mission. Their appearance gave the public a personal look at what the journey was like. Such media spots help inspire the next generation of space explorers. The crew highlighted both the challenges and the rewards of space travel. It was a chance for them to connect with viewers back on Earth. Europe's Sentinel-1D radar satellite has begun operations. It is expanding the continent's radar observation network. The satellite will support monitoring of land, sea, and emergency response efforts with improved data. This addition improves the quality and frequency of data available for various applications. Radar technology allows observations regardless of weather or daylight conditions. The data will be valuable for environmental monitoring and disaster management. This marks an important upgrade to Europe's Earth observation capabilities. NASA plans to increase the value of its Commercial Lunar Payload Services, or KLPS, contract for robotic lunar missions. The change is intended to handle a growing number of lander flights. These missions support the development of a future moon base. Expanding the contract shows confidence in the commercial sector's role. More landers mean more opportunities to test technologies and gather data. This step helps accelerate the pace of lunar exploration. It demonstrates the agency's commitment to using private industry for lunar delivery. Morocco has joined the Artemis Accords. The country is committing to responsible space activities. This agreement reinforces international cooperation for lunar and deep space exploration. Joining the Accords signals a dedication to peaceful and sustainable practices in space. More nations participating strengthens the global framework for exploration. It opens doors for future collaborations between Morocco and other spacefaring countries. This move adds to the growing list of partners in the Artemis program. Next time, we'll be watching for the Starship test flight scheduled for May 12th. It should give us more details on the progress of that vehicle. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at @Nera Network. Links in the show notes. This podcast is curated by Patrick but generated using AI voice synthesis of my voice using 11 Labs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
Drifting softly through the black.